Okay, so this is our Black & Decker coffee maker. We're going to take a look at what it's made out of and how it works. This is the coffee holder and the carafe or whatever you would call it. And so it's made out of a glass, and I believe the way this glass is made is it's heated and blown into a mold, and then it's allowed to cool, and there's a little, while it's still molten, there's a mechanical device that creates the shape for the spout there. And this is a band of stainless steel that wraps around the edge here. It's molded into the indent in the glass, and there is a handle here. This handle looks like it's made out of polypropylene. It's a fairly low-cost plastic. It's no texture on it or anything fancy. You can actually feel some of the mold seam there, but it's a very low-cost handle. And you can see this part just pops out. It's got a snap fit there. And again, polypropylene lid and handle. And so it's that stainless steel piece there really does a good job of holding all this together. I think we can probably pry this handle apart and see what is inside of it. I might need to get a larger screwdriver. I should say a smaller screwdriver, so I can pop this apart and see if we can see what's on the inside of it. It's not meant to come apart, and it may be solvent bonded or something like that, so we may not have a lot of luck with it, but we'll give it a go. Oh, it's not. It's just a snap fit. Okay, so you can see that's how they molded the part. There are two different pieces there, and we're going to go ahead and remove this screw here to show you how it all goes together. All right. Oh wow, pops apart there. So you can see there's a little bracket on the inside that the screw goes into and holds this steel band in place, and that's what the handle is held on by. And then at the top there's just a little lip that holds the top of the handle there in place, just a little piece that like folds over the glass and snaps on. And so that's how that's held. So this is made out of one molded part, this is made out of another, and this is made out of another, and so that's how they made the handle. There's three different molded plastic parts there, and the mold came together like this, and you can tell that because you can feel the mold seam on the inside of the handle there. And you can also tell it because of the way the handle's shaped, that it would make it easy to pull the mold out this way. And they probably also had, it was probably a three-part mold, and there was a section that also came out in this direction. And yeah, and then this is just another injection molded part that snaps onto this one, as we've seen. And this is the part that holds the handle on. Very important part. And I think they definitely paid the extra money for a stainless piece there, because it's really important that doesn't come loose, and it probably gets fairly wet, and so if it was made out of regular steel or another material, it might rust and could potentially come apart, and we wouldn't want hot coffee on us, now would we? Alright, so that's that is the coffee kettle. Alright, so inside, here's our coffee maker. So we know that hot water, we've got a container here, and in this container on the inside of the coffee maker is a space where we put our coffee filter, and then we put our coffee grounds, and we fill this with water, and then we close the top, and we turn it on, and we wait. And what happens is that hot water, or that water that we pour in, drains down a little spout, or drains down a little hole on the inside there. You can see it right there. You point to it with the screwdriver. Drains down that hole, and it goes down into this underside. So we'll take a look at the underside and see what happens down there. Okay, so I've modified a screwdriver. This was a low-cost screwdriver. It was a 99-cent one, so I modified the end of it so I could take out these safety screws. Don't do this at home unless you have a professional with you, because this is not meant to be taken apart. That's why they use these special screw heads, so you won't take it apart. But I did want to show you what was inside. And there we go. Okay. Again, this is an injection molded part. This is a co-molded part, it looks like, which means that there were two different materials molded together. And let's see if I can knock that screw out. Okay, it wants to stay, that's fine. Okay, so this material here is these feet are made out of a softer material, and this is a polypropylene material, and so it's plastic, a low-cost plastic. So the mold comes together and they injection mold this material, and then once this material has begun to harden, they injection mold the softer material. So it's co-molded, or it's a dual molded part. And you can see other parts are done like this. Like sometimes you'll see toothbrushes that have a soft Santoprene and then the hard toothbrush, and they're molded in one mold. It's a dual shot mold. In any case, so that's the bottom, and this allows heat to get into, or allows air to get into the heater chamber to vent out, I think a little heat in there. And so here is the heater. This is where all the magic happens. So the water comes down this tube, and it goes around this horseshoe shape, and then it comes up here. And what causes the water to raise back up and go all the way up this tube, which it does, goes all the way up the tube here, and then it comes out this apparatus here, and it goes and drains out of these holes right into here. And there's just a little piece of plastic that causes this part to line up right over the top of this when you close it, and then water just comes up that and drains right out into your coffee grounds, and then makes your coffee. So the heater does two things. It causes the water to go down this pipe, expand out, and to drip into your coffee maker, but it also heats up the plate, this plate right here. And so the way it does that is it uses a material called nichrome wire, which is it's a alloy of nickel and chrome, and it heats up really easily, and it's a good resistor. And so when it heats up, the aluminum is also an excellent conductor of heat, so it conducts heat very well into the plate and also into the water that's inside of it. And there are a number of different safety mechanisms inside this coffee maker. We've got two thermal fuses here, and if it gets too hot, those will blow and prevent it from getting hotter. There's also a temperature sensor here that can shut the coffee maker down if it gets too hot. And I believe what's inside of that is a bimetallic strip. And so it could be a strip that has something with a low thermal expansion coefficient, like Invar, which is an alloy that doesn't expand very much at all in heat, and then it could be alloyed with another metal like, say, copper, which expands fairly well in heat. And so what happens is when those two metals are next to each other, one of them, the Invar, doesn't expand very much, so it sort of sits still, but the other one expands, and it causes the bimetallic strip to bend like that. And when it bends, if it was conducting the electricity, it moves away from the contact. So let's say this is the contact here. It moves away from the contact when the temperature is too high. And so they choose those bimetallic pieces based on, they calibrate them based on how much temperature they think it's going to take. So they'll pick how much, the size of the metal and the amount of metal and the types of metals that they alloy together for that strip are based on the temperature that they want the coffee maker to get to. So they don't want it to get to like 500 degrees or anything close to that. So there's probably a temperature that they have chosen, and then they select a bimetallic strip that will respond to that temperature and shut the circuit off. And I think that's how this temperature sensor will work. So we're going to go ahead and take apart the rest of this. So this piece right here is kind of cool. It's a little bar that holds the heater in place. And this little bar has these screws on it, and the screws have these curious little washers on them. And the washers are made out of a fibrous material that does not conduct heat very well. And that is very helpful because you don't want the screws conducting heat into the plastic, into this, because otherwise if they conduct the heat into the plastic, then the plastic will potentially get soft and deform and maybe even melt. So we don't want that to happen, so that's why we isolate the this bar that holds the heater in place. So we're going to continue to take these screws out here, and the screws are set in something called a boss, a screw boss. So that is just a protruding piece of plastic on the inside that holds the screw in place. And you can see that the heater is held in place. It's got this it's got this paste around here, and that's called thermal paste, and that aids in the conduction. It helps the hot temperature to be conducted from this horseshoe-shaped heater to the steel plate that the coffee maker sits on. And so we're gonna take these screws here out. So these screws hold the plug in place, or the wire in place, and you'll notice that the wire is looped around itself, and that is so that you can't pull the wire out of the coffee maker. And that's important because you don't want to pull loose any contacts, because if you have any loose wires in the coffee maker, potentially that's a cause for a fire or an electrical short. So we don't want that, and that loop helps to prevent that. And if we go down a little further here, I think we can take this part here loose. We're taking the two halves of the coffee maker apart, and you can see, I don't know if you can see inside of that very well, but down in there there's a little symbol that says PP, and that stands for polypropylene. So that's how we know what kind of plastic this is. And polypropylene is a low-cost plastic that's widely used in commercial products. One of the lowest cost plastics. They use it in everything from dishwasher tubs to you name it, coffee makers, to hair dryers. In any case, I'm trying to get this screw out. It's kind of in there pretty good, and you can see, like, as I'm taking these screws out, it's separating. The two halves are separating. So there. See if we can finish getting this apart for you. Alright, we've got one more screw here. Okay, so you can see this is how the two halves of the coffee maker come together. Whoa! All right, so they come together like that, and you know, there's a bunch of screw bosses here, and they actually line up with holes on this side so that you can press the two pieces together. So these two halves are injection molded. The molds come together like this, and then the two parts come together, and that's how they're able to create this shape. And you can see that the water comes in this tube here, gets heated, and rises out this tube here. And this right here is the ring that went around the inside right here, and this is the metal plate that the heater sat on. And so there's a separate ring here that the metal plate sits inside of, gives it a nice finish. And yeah, I think that's about it for our coffee maker. That's how it works, and that's what it's made out of. Hope you've enjoyed it.